If you listen to an audio file, you might be able to guess which instrument was played. But if you look at a single point, it could have come from any instrument. Classifying a point is impossible without the context of the rest of the sequence. Recurrent networks are designed for applications where the input is an ordered sequence, and the information from earlier in the sequence may be relevant. These networks are often used to classify data like signals, time series, or text. Recurrent networks contain layers that reuse the output from a previous step as input for the next step. Like all neural networks, the node performs a calculation using the inputs and returns an output value. In a recurrent layer, this output is then used along with the next point as the inputs for the next step. Most recurrent layers also have an internal state, which is used to store and retrieve information over many time steps. The input value, previous output, and the internal state are all used in the node's calculations. The results of the calculations are used to provide an output value and to update the state. Like any neural network, recurrent nodes have parameters that determine how the inputs are used in the calculations. However, they also have parameters called gates that control the flow of information within the node. For example, there's a parameter that controls how much the saved state is used as input to the calculations. These gates make recurrent layers better at learning the complex interdependencies in sequences of data. Ultimately, they're still just a node with a bunch of parameters. And these parameters are learned during training, just like with any other neural network. Recurrent layers can predict the class for every time step in a sequence. This is useful for applications where the output class of the sequence changes over time. Or you can predict a single output class for the entire sequence. In this case, the last output is used to make the final prediction. Either way, the recurrent network still takes a sequence as input, and the output is informed by the previous elements of the sequence.